phases are equal in magnitude and displaced from each other by the equal magnitude. If we call as a system balanced system, because if voltage and the current are in phase equal, like as a we have the three conductors like R, Y and B. If both of the three as the like 120, 120 and another 120, so then the phase difference between the three is like 360. Only have the circle, we have the 360. So 120, 120 and 120. These types of the 6 you call as a balanced system. Like so in the balanced system, all the phase will be in the equal magnitude. You can as the in the alternating current. Then the maximum point is as a peak point, and it's called as a means amplitude of the amplitude of the system. And another definition is the balanced load, in which the load in all phases are like in equal magnitude and the phases. It means that the loads will have the same power factor and equal currents in them. Like one definition and the one another words, like as what is the power factor. Power factor also when we have any device, any system in the like any electrical and any electronics, what is the efficiency of the systems. It is the main and our goal is like we manufacturing one item, so then our main goal is like as a efficiency. So the power factor we call as a efficiency, and the power factor we call as a ratio of the between the actual, what will be the actual power, and the another will be the when we as a supply. So like as a efficiency, and the another electrical term when we use in the third sem and the fourth sem, the gain, the power factor and the gain. So all the power factor and the currents will be the same. So the power factor we call as a efficiency. And what is the relation between the power factor in the voltage and the current? Then it will be the next topic in the next slide. We have the power relationship between these in the delta connection as well as the star connection. Then the unbalanced load, like why we call as the unbalanced load. In one band is one which the load in all the phases will have unequal power factors and the current. Like we have the unbalanced load, we call as the we have the different power factor, and also we have to the different angles, and also we have the different values like of the current, and so we call as an unbalanced load. In the our topic polyphase circuit, also we have discussed only the what is the balanced load and what is the balanced system, and what is the analysis of the balanced load and the balanced system with the example. So you can understand how we define this is the balance and this is the unbalanced, and what is the major difference between then the balanced system and what is the balanced load. And also you can gain the efficiency, how you can the efficiency in the balance and as well as the compared to the unbalanced. Then the next topics, then the connection between the generator and the load, how we define as the what is the like as a significance, what is the star connection and what is the delta connection, how you can define how you define then, and how you connect then the three conductors in the star and as well as the delta connection. First we call as the star to star. First we call as a three coil, like first, second and the three. We call as in the star connection, like we have the call as the interpret as the star, because 1 point, second point and the third point, and the second is the and the delta, like we call as a triangle connection. In this system we call as a triangle connection. It will be the delta. First will be the only the coil, and the like as we call as a inductor coil. Second is the load. Then the combination. First one coil is the star to star, second is the delta to delta, and third one is the combination. How to we convert star to delta and delta to star. Also first we call as the means analysis of the star connection. Second one is the delta connection, and what is the relation between star to delta and delta to star. First we call as the terms and naming convention. So it is the elliptical words. What is the terms and what is the naming convention? Like you have to means I speak more than times, like as a phase. But what is the phase and what is the line and what is the natural means neutral? Like I as a neutral. What is the neutral? Then the term one the define as the phase, line and the neutral. we have the three phase, like so we have the three terms. What is the phase? Like it describes or pertains the one element or device in a load, line or source. It is simply the branch of the circuit. Like we have the means defined as the one will be the in the means load, line or the source. Between then the connection between in the circuit we simply call as the means as the branch. Then the second one is the line, and it refers to as the transmission lines or the wire that connects the source to the load. Like we call as a means simple definition, we call as a connection between output and the input, and it may be modeled as a small impedance compared to the three, because it will have the more connection and the long distance connection. We simply call as the output and the input. And the neutral we call as the fourth wire in the three phase system, and it will have the phases of the wire connection will be the come together, like as the earth point we call as the neutral point. So that is the three terms: what is the phase, what is the line, and what is the neutral. We have to remember the terms will be the very clear, because always we derive the equation of the in the star connection or the in the delta connection, or star to star, delta to delta, and star to delta, delta to star. Only the three terms are very important, and depends only the three terms. So I explain the first three terms: what is the phase, what is the line, and what is the neutral. And you can define as a means, and you remember what is the phase, line, and the neutral. So you can remember as a what is the connection between the phase line and the phase connection and the line connection, and what is the in the neutral connection. Then the next topic, first connection, what is the star to star connection, and how you can define as a star, like R, B, and the Y. And the another is the what is the star connection, and with the what is the natural, where is the natural points. So the neutral points, like it will be the neutral points, not the nature, it will be the neutral points. So you can as a define as a neutral point, like R and the B. And the what is the how we will define as the phase and the line, it will be the in the next style, all the definitions, what is the phase, what is the line. But only the neutral point you can define as. Then the three phase will be the together at the one point, we call as the neutral point. In what is the significance of these points, and another phase and the line, it will be then the next slide. But what is the importance of the means neutral? With the neutral conductance, the system is known as a 4-wire star connector systems or the 3-phase 4-wire system. Then the next, if we have the two types of the balance, and we have the two types of the one is the balanced load and another is the unbalanced load. In the balanced load, the resultant current in the natural conductor is 0. Like in the balance, the 3 points will be, because we have all the equal power factors and all the values will be the same, so it will be called as the 0. Like we have to the equal currents mean have in the electrical subjects only we have to equal currents mean it will not the same at the value, like one is the plus 5 and the one is the same is the plus means minus 5. Is also why we call as the equal, the algebraic sum of all the current is equal to 0. So it will be the major difference. What is the equal current? So it will not the means same at the in the mathematics like plus 5 and minus 5. No, we have the algebraic sum of the all the currents will be the equal to 0. So in the balanced system, like then the another, it will be the what is the without natural conductor, like we have the unbalanced systems. And without the natural conductor, what will be the without natural conductor, the system is known as the 3-phase wire star connector system or 3-phase 3-wire systems. So then the difference between natural points and the like as a neutral points and the without the neutral points. Why means you can as a difference between this called as a 3-phase 4-wire system, because we have the another point is a neutral. In the system we call as a second one is called as only the 3-phase 3-wire system, depends only the neutral conductor. And the next one, what is the definition in the star configuration, and how we'll define as the voltage, because we have to the three R, Y and the B, and what is the line and what is the phase, because past slide we define as what is the neutral point and what is the effect of the neutral conductor. So then you can define as what is the system, like 3-phase 4-wire system, 3-phase 3-wire system. It depend on the neutral conductor. Then another thing, phase, line and the neutral. It will be three. It's a very most important, and always you have to remember three terms in the star connection and the delta connection and the power relationship. So we have to first the definition in the how we call as the define what is the line voltage, what is the phase voltage and the line current and the phase currents, and what is the power relationship will be the in the next topic. So first we call as the in the star connection, we use the star configuration and there will be the star connection. So we call as the in the electrical system, another way we use the configuration, and the another one connection without we call as a configuration. So the first means what is a line voltage, like as the ERY, but then the E means YB and the EBR, like ERY, RY and the B. So RY, YB and the BR we call as the line voltage as the generator, because we have to give the 3-phase supply, like we have a 230 volts, it will be the RY and the B. So we call as the RY and it, so it called as the line voltage. And what is the low voltage, like as a VRY capital E and the VRY and the VYB and the VBR we call as the line voltage at the load. Then the second is the second term, like as a phase voltage. This is the line voltage and the Y. So that according to our definition, line voltage we will call as a transmission line. So we call as a connection between the output and the input. So the input is our call as a generator and output will be the load. So the line voltage defined as this. And the another term is the phase voltage. How to the phase voltage? Then the ERN, EYN and the EBN, so called as the phase voltage at the generator. So according to our definition, the another point in the phase voltage will be the source, device and the another connection, but the second is with the connector will be as a neutral. So we call as a, according to it, call as a phase voltage. Then the another term is equal to capital VRN, VYN and the VBN. It will be the phase voltage at the load. And in the star configuration, the line currents is equal to the phase currents. And how this will be the possible in the next. Then the definition is according to the in the delta configuration. How will be means call as the will be the in the delta configuration. First we call as the line current, and the in the line current IR, IY and the IB is called as the current in the conductors, and the phase current like RY, then the RYB and the RBR, then the currents to the phase. In this delta configuration, line voltage is equal to the phase voltage, like as the VRY, VYB and the VBR. How will be the and will be the next? What is the voltage and the current in the star connected systems? In order to understand the relations between the line and the phase voltage, a star circuit, understand the following we can call as the means like as a figure. Like we have the two connection, like first is the R and second is the B, using KVL like Kirchhoff voltage law, and another we have the means find as a two system like Kirchhoff voltage law, and the another like as a you call as a algebraic sum of this R, Y and the B. First, then the VRY is equal to VRN plus of minus VYN is equal to VRN minus VIM. So it will be called as the another like as a circuit, if you can as a phasor diagram. How we call as a VRN minus VN is will be the next topic. First we have now assumed the magnitude V for the each voltage and the take VB as a reference. Then the sequence is R by V is balanced. So all the voltage is displaced by the 120 from each other, because we have the balance system. All these means relations between voltage and current in the star and as well as the delta we call as the defined in the always in the balance systems. So because we have the difference means interaction between only in the balance system. First, then the VRN, V is equal to the zero angle, like first we will as a zero angle, then the VIN is equal to the minus 120 and VBN is equal to the plus 120. And substituting, how we define as the VRY, then the first we were the VRN minus VYN. Also you can define this is the VRN minus VYN, because we have the current direction between this downside. So you can as the according to the Kirchhoff voltage law, first point is the plus in the R type of the resistors, and in the Y we call as the first sign is the minus negative. So then we call as the minus VYN. It will be defined as the Kirchhoff voltage law. And also you can find this is the VRN minus VIN by the phasor diagram. Then another is in the next slide. First we have the VRN, VRY. So we call as the VRN minus VIN according to Kirchhoff voltage law. V of in is equal to the zero angle, then the minus V is equal to minus 120. So the 1.723 as angle will be the 3. 1.723 is called as the under root 3 V angle of the 3, and so it will be the same. The VYB is equal to, also you can define as the VYN minus VBN is a root 3 VBN minus 90 degree, and in the VBR is called as the 150 degree. You can define as the same procedure at the VRN minus VYN. Then what is the conclusion for the voltage and current in the star connection? In the only for the balanced star connection, otherwise derived from the KVL, like we call as the two types of the means method. In the phasor diagram you can see the first the red line, then we call as the VRN, at it will be the 0 degree, then the VBN, then the another is the like as the VYN, and also you can as the VRY, VYB and the VBR. It is also defined as a 120 degree from the each other. Then you can define in the previous style, then the VR is equal to root 3 into VR into 30 degree, like